Hi, Math 110, section 1.6. These are some problems that they all have a different way of solving it. It just shows application of the second degree equations. So here, you start with problem number 2. How would you solve this? First, you need to do the factoring. The very first method of factoring is between 9 and 21, they both have 3 in common. And x2 and x4, you take the one that has a lower power. So when you take this out from each of this, the remaining would be in the parentheses. How do I know this factoring is correct? You could just take 3x2 and multiply by 3x2. That would give you 9x4, or 3x2 times minus 7 is 21. Then you take each of these and set equal to 0. So here, if I divide both sides by 3, 0 divided by 3 is always 0. How do I know that? You could use your calculator. So 0 divided by any number is always 0. X to power of 0 is 0. What number to power of 0? What number to power of 2 is 0? Is 0. So that's 1. And that's how you find the second one. Remember, when you solve for x, you should always put a plus or minus because there are 2 possibilities. Okay? Like here, in this example. x2 is equal to 9. What possibility are for x? X could be 3 and negative 3. Because either of these 2 numbers, when you raise it to second power, is 9. But if the power is odd numbers, there is only one value. So what number to power of 3 is 8? Just 2. So with odd number, there is only one possibility. With even number, there are 2 possibilities. That's why here we have 2 plus or minus 2 value for that. This one, to do the factoring, first I have to bring all the term to one side and set it equal to 0. This is group factoring because you have 4 terms and they don't have any number in common. So group factoring, you divide it into 2 groups. The first one, x3 and x2, the lower one is x2. I factor that out. Second one, now, one thing about the group factoring is when you find the first parenthesis, you could always take it and put it here for the second one. You don't have to worry about factoring the second one. All you need to do is just figure out when you put this x minus 6 and put it here, then you need to have minus x plus 6. So that means the number outside of x minus 6 has to be negative 1. And then x2 minus 1, x minus 6, x2 minus 1. This is a formula we had in the factoring. Difference of 2 perfect square is this. So x2 minus 1 to power of 2 is x minus 1, x plus 1 times that. Then you take each parenthesis and set it equal to 0. So there are 3 answers or 3 solutions for this problem. The highest degree of x show total possible numbers. So if this is 3, means you should have up to 3 solutions. Now, the next one also is the group factoring. So I'll bring the 1 to this side first, break it into 2 groups. x4 and x3, they both have x3 in common. I factor that out. I'll take this x minus 1 and I'll put it here. Now, the factoring is this. But now I have to also use the formula for this x cubed plus 1 cubed. When you have sum of 2 cubed, you get to break it like that. So this one, it turned to be x plus 1 times x2 minus x plus 1. Okay, you already have x minus 1. When you take each parenthesis and set it equal to 0, these 2 would give you 2 real numbers. But the last one, when I use the quadratic, under the radical I have negative. Is negative 3. And negative 3, remember, negative radical negative 3 is radical 3i. So for radical negative 3 here, we are using that. Well, before I work on this problem, think of this. When we ask you to solve these problems, a to the power of 2 minus 4a plus 3, what you do is you open two parentheses. You take the middle term, which is a in each, and then you find two numbers whose multiplication is positive 3, and when you add algebraically, it's negative 4. Those two numbers are negative 3 and negative 1. When you multiply these two, is positive 3. When you add algebraically, is minus 4. So then you take each parenthesis and equal to 0 to find your, in this case, a. So we use this property because the power is 1 and the power is 2. This one, the power is always double. Means if the power is 1, when you multiply by 2, you get this one, right? So we use this same property here for these problems. For these problems, it's very similar to that. See, the power is 2. If I multiply that by 2, it gives you 4, right? So what I do is you take x2 and put it in each parenthesis. And then you need to find two numbers that when you multiply is positive 3, and when you add algebraic is negative 4. Those are these two numbers. Now when you take each parenthesis and set it equal to 0, then you are using this formula in factoring to break each of this. So you end up having 4 parentheses. So when you take all parentheses and equal to 0, then you have 4 answers. See, there are 4 answers, and what's the highest power of x4? So the total possible numbers are 4, or solutions are 4. This is the same thing. It's very similar to that. See, the power is 3. When I multiply that by 2, is 6. So in that case, you put the middle one. You know how you put this x2 on each? Now you put x3 on each parenthesis. Then you find two numbers whose multiplication is negative 8, and when you subtract is positive 7. These are two, 8 and negative 1. Now, I use again the formula of a cubed and b cubed. I have a formula here. See, this is a formula that we need to use to break these two. If it's a negative, start with the negative and positive. If it's positive, so we are using these two formula to break all this. Two of the parentheses give you real numbers, and the other one you have to solve it. They both give you two numbers here, two answers here. Two answers is 4, 5, 6. 4 complex numbers and 2 real numbers. So all together is 6. See, the highest power of x is 6. So you have up to 6 answers. 2, 2, 4, 5, 6. So far, this is what you learn. If you take power of 2 and multiply by 2 is 4. If you take this 3 and multiply by 2 is 6. And now on this one, first of all, you write radical x is x to the power of half. It's the same thing. If I take this half and multiply by 2, what do you get? 1. See, they all are very similar. So in that case, you take the middle variable in each parentheses. Here, to make it easy on yourself, I made an assumption of a. So I would assume that if this is a, then when you raise both sides to power of 2 is a2. Either that, or right here, you could just say, okay, I'll open two parentheses. I put x half in each parenthesis. See, this is another way to do it, right? And then you need to do the rest. But here, this is different with the other one because you have a power is 4, so it cannot just be x and x. Because when you multiply that, it gives you x, but not 4x. So in that case, we made the assumptions. And when we do that, we come up with these equations. How do I solve this equation? You have to use the group factoring. Instead of 7a, you write 8a minus 1a. 8a minus 1a is 7a. This is a type of polynomial, or the polynomial with 3 terms. If the number in front of a2 is not 1, then you have to convert this to group factoring. So positive 7a, instead of positive 7a, we write positive 8a minus 1a. Now is a group factoring because there are 4 terms. We break it into 2 groups. We factor it. We put each parenthesis equal to 0. Then at the end, when you find the a is 1/4, right? What was the assumption for a? A was x to the power of half. So now you could replace it to x to the power of 1/2 here. Radical x to the power of half, which is radical x. So when you raise both sides to the power of 2 is this. The other one, when you do the conversion, radical x is -2. That's not possible. So this is undefined because radical cannot be negative, especially if the root is 2. Anytime you want to solve radical equations, you have to isolate radical on one side and numbers on the other side. Then I raise both sides to power of 2. When you raise both sides to power of 2, radical is removed and it's 36. What's the reason? Look at this. I have radical a and I want to raise it to power of 2. What does that mean, radical a to power of 2? It means take radical a and times radical a, which made it finally a. It means anytime you take a radical and you raise it to power of 2, radical is removed. Same thing here. First, I want to isolate radical. Take 2 to the other side. When you have a cubic root, it's okay to have a negative on that side. When root of radical is odd, it's fine to have a negative on this side. So when you raise both sides to power of 3, what happened? Radical is removed on this side. So 2x plus 4 is released, and you find the x. And you could always check, if I take this minus 6 here, and 2 times minus 6 is minus 12 plus 4 is minus 8. Cubic root of minus 8 is -2 plus 2 is 0. Same thing here. You keep radical on one side and numbers on the other side, raise it, and then that gives you the value of x. This is a long one. So when I raise both sides to power of 2, remember, don't just say this is x minus x plus 2. Anytime you take the difference of 2 terms and raise it to power of 2, there is always a middle term. Some students make a mistake and they don't realize that there is a middle term when you take a minus b to power of 2. It's a2 plus b2, but there is a middle term. So here, when I take this and raise it to power of 2, radical x to power of 2 is x. Radical x minus 3 to power of 2 is x minus 3, but then there is a middle term minus twice of this. Then when you simplify, you try to isolate radical again on one side, divide everything by 2. So now radical is by itself on one side. Now when you raise both sides to power of 2, radical is removed. And remember, this one again, according to this formula, it has a middle term, which is minus 4x. And that gives you the value of it. Anytime you solve a radical equation, it's always a good idea to check. And I did check, and it works. Problem like this, if I want to raise both sides, I raise it to reverse of this because I want to get rid of the exponent. So if this is 3/2, I raise both sides to power of 2 over 3. Then x minus 4 has no power, and this is how you solve it. Like here, I raise both sides to power of 2 over 3. You see that? This becomes 1, so it's just x2 minus 5. And here, 3 times 2 over 3 is 6 over 3, which is 2. This is fractions. You take a common denominator and then you cross multiply. Here is a cross multiply. Remember, when you have cross product is when you have a over b equals c over d. A times d is b times c. This is a cross multiplication or cross product. We use it right here. 1 times 1 is 1 times this. Now, write the equation. What if we give you two numbers and ask you to find the equations, okay? Look at these problems here. What if I give you answers to the problems and ask you to find the general equation? How would I do that? X is 1. You put the opposite of 1 here and opposite of this here. You multiply, that gives you the original equations. When we ask you to solve this equation, you come up with answers, right? What if I give you the answers and ask you to find the original equations? So in that case, when you have the answers, like this is 1, you put x minus 1 here. If this is minus 3, you put x plus 3. Then you multiply this to get the original equations. Okay? We use the same property here. Look, two answers are given. I and minus I. What is the opposite of this? Minus I. What is the opposite of that? Positive I. When you multiply this, that give you the equations. This is how to find the original equations. So this is section 1.6, Math 110.